Cats are just like living with other adults.
This episode is sponsored by Front End Masters. They have a terrific lineup of live courses you can attend either online or in person. They also have a terrific backlog of courses you can watch, including JavaScript the Good Parts, Build Web Applications with Node.js, AngularJS in Depth, and Advanced JavaScript. You can go check them out at frontendmasters.com. This episode is sponsored by Hired.com. Every week on Hired, they run an auction where over 1,000 tech companies in San Francisco, New York, and LA bid on JavaScript developers, providing them with salary and equity up front. The average JavaScript developer gets an average of 5 to 15 introductory offers and an average salary of $130,000 a year. Users can either accept an offer and go right into interviewing with the company or deny them without any continuing obligations. It's totally free for users, and when you're hired, they give you a $2,000 bonus as a thank you for using them. But if you use the JavaScript Jabber link, you'll get a $4,000 bonus instead. Finally, if you're not looking for a job but know someone who is, you can refer them to Hired and get a $1,337 bonus if they accept the job. Go sign up at hired.com/JavaScriptJabber. This episode is sponsored by Rackspace. Are you looking for a place to host your latest creation? Want terrific support and high performance all backed by the largest open source cloud? What if you could try it for free? Try out Rackspace at javascriptjabber.com/Rackspace and get a $300 credit over 6 months. That's $50 per month at javascriptjabber.com/Rackspace. This episode is sponsored by Wijmo5, a brand new generation of JavaScript controls. A pretty amazing line of HTML5 and JavaScript products for enterprise application development in that Wijmo5 leverages ECMAScript 5 and each control ships with AngularJS directives. Check out the faster, lighter, and more mobile Wijmo5. Hey everybody, and welcome to episode 142 of the JavaScript Jabber Show. This week on our panel we have Joe Eames.
Hey everybody.
Dave Smith.
Hello, world.
AJ O'Neill.
Yo. Still coming at you from Provo.
Jameson Dance.
Hi, friends.
I'm Charles Max Wood from devchat.tv. Quick reminder, go check out JSRemoteConf, jsremoteconf.com. We also have a special guest this week, and that's Joseph Gentle.
Hi, everybody.
Do you want to introduce yourself real quick?
Sure. So I'm Joseph. I worked on Share.js, and I've spent the last 2 years working at Lever, although I quit a few months ago. I used to work on Google Wave, years ago before it got cancelled, and I've sort of spent the majority of my time since then programming, trying to rebuild a lot of the tech stack that we had since then, and put it in a Node.js world.
Google Wave? That's awesome.
Yeah, I know. It's totally my street cred now. Yeah, no, it was great. I find it really interesting now because I talk at conferences and things sometimes, and I always ask people whether they heard of Google Wave, and there seems to be fewer and fewer people who know it. But
no.
yeah. I don't know. It was a great piece of tech. It was crazy. The team was crazy, and it failed for all sorts of completely sensible reasons. But yeah, I'm really glad to have worked on it. It was fantastic watching a big company implode in on itself and destroy one of its clients' possessions.
Google Wave it's like that obscure indie band that goes on to inspire lots of, a whole new genre of music or something.
No. Google Wave is like web TV. It just came 15 years too early.
Wait, are you saying that web TV? Oh, wait. That is kind of a thing now, isn't it?
Well, I mean, Netflix, right? I mean,
web TV, and Justin TV, aka Twitch, that's just been sold to Google for some ridiculous. No, yeah, Wave was super too early. We had a team of 60 engineers working on it, which was way too many engineers. That's it was 1.1 million lines of Java when all was said and done.
What could possibly go wrong?
Well, exactly, right? But then at the same time, all of the people who used to work on the Wave team, one or two people ended up co-founding Firebase. Google Wave bought Etherpad, and then when the Etherpad guys left Google again, one of them went to, as one of the co-founders, so David Greenspan, as one of the co-founders for Media. I've gone and done Share.js. I think there's Google Wave people everywhere now, and we're just quietly incepting the world on a whole bunch of the OT code and stuff.
So what year was it that Wave was finally canceled?
Can't even remember. It was several years ago.
Was it before the iPhone came out?
It was around... No, the iPhone had come out a year or two before then.
Okay.
It was sort of IE9 days. The web browser was... browsers were terrible back then. It got released in May of 2009. It got cancelled in August of the same year. So,
okay.
yeah, The browsers were terrible. We had a like internal, we use Wave for everything on the Wave team, maybe unsurprisingly, but we had this giant Wave that like scrolled for more than a page, which was all of the open web browser bugs that we found through the process of making Wave. That we had open like tickets and stuff on different browsers. Like we pushed the browser really hard, which was something that people didn't really do back then at all. You know, and like in all sorts of weird ways, including our own scroll bar, which was a terrible idea. But yeah, I don't know. It was what it was. Yeah, like and the client took like it was like several hours of CPU time to compile on Google's like internal data centers. So it only took about 5 minutes of clock time, but it compiled down to like 350K of JavaScript compiled through Gwt. And, you know, because that was probably like, it was seen as a good idea back then. It was launched in 2009, but I think work started in about 2006. And like Node.js was not a thing then. Like Node.js was barely a thing when I left Google and started Share.js, which was right after, and I was working on Share.js against Node.js 0.4. Like it was a, you know, crazy weird little thing that I just did for fun because, oh hey, this Node.js thing looks cool. Like this is before NPM was around. Like the list of packages was a page on a wiki somewhere. It was on a wiki, it was on, I think it was a GitHub like markdown document that you could submit pull requests against so that you could have your package added to the markdown file on Node.js itself. But yeah, I mean, like that's the state of Node.js back then. And yeah, like it's easy to forget how much time's passed, how much better our browsers have gotten in the last few years. Like now you can take for granted the fact that we've got, you know, a modern version of Chrome, a modern version of Firefox. If it's IE, then at least it's going to be IE 9 or 10, hopefully IE 10, 11. Like even IE is now, you know, semi-modern and you can just assume that. But back when Wave was around, like we got a huge amount of crap for dropping like old versions of IE support. And like that's probably reasonable. Like we just straight out ran out of man hours. We had a version of Wave working on, I think IE 7 for most of the development period, but it took about, but like it's loading 350. But people were using IE 7 back then. So like if we wanted to be compatible, we needed to. Except that like IE 7 loading 350 kilobytes of JavaScript, it took like a long time. Like it looked like the browser had hung while it was loading all the JavaScript, and it was a terrible experience. Yeah.
I can totally see that. Have you gotten on Wave yet? Well, I opened it. I'm going to go get lunch.
Just for the benefit of our listeners who may be wondering why we're talking about Wave with a Share.js topic today, Joseph, can you tell us how Share.js came to be and how it relates to Google Wave back in the day?
So Google Wave, for all the people who haven't played around with it, and unfortunately this is not an experience you can have anymore, the original idea was that we should have this sort of like, these things that are kind of like emails, but also kind of like Google Docs, where you can invite more people to them and then have a conversation in the document, and everyone can just see each other's changes live, and everyone can make changes, everyone can update each other's comments, and then it just adds you as an author to that comment as well. And like, it's this sort of like weird technology that we didn't really know what people would use it for, and it took us a while to figure that out. But when Wave got cancelled, I mean, like, it's a great idea. Like, this is something that we need in the world. I want to have the, you know, someone called it the glorious messaging bus in the sky. That, like, part of the other idea with Wave was that it should be federated, so you should be able to run your own Wave server the same way you run your own email server. And then if I, like, start a Wave with you, then my server and your server talk directly, and there's no, like, you know, there's no Facebook reading all of my messages. It just goes between respective servers at our companies.
Mark Zuckerberg just rolled over in his grave.
He's alive, Joe.
Yeah.
I was trying to figure out how to break that to you.
It was a preemptive role.
Anyway, but when Wave got killed, I was like, oh, this code doesn't need 1.1 million lines of Java to work. So I rewrote it in about 2,000 lines of JavaScript just on top of like modern web stuff. And it worked great. And that's what Share.js originally was. It was just this like, you know, it didn't do federation. It didn't do all sorts of things. It didn't do rich text. It was just like, you know, this simple world for doing collaborative text documents and having that work as a simple library for people making web apps, which is something that it still is. Like I messed around with the idea of it a fair bit, and it ended up being this like fabric for not just text, but also we've added rich text to it, and we've added JSON OT support, so you can have arbitrary JSON documents and do collaborative operational transform operations. So you can collaboratively edit a JSON document with some other people. But this is me totally like giving a spiel about my own toy, which
that's great.
Is.
So you said OT and operational transform. Can you tell us what that means?
Right. They both mean the same thing. OT just stands for operational transform. OT is it's a set of algorithms that were developed. I mean, and the OT algorithms that Share.js uses are from 1995 or something. This stuff's been in academia for a while. The core algorithm, basically the way to think about it is real-time, subversion. It's crappy real-time Git. That's what the algorithm is. That means that every change that you make is this sort of special commit in a sense that then gets propagated immediately to everybody else. And in the same way that something like Git can handle merges. So if two people are collaboratively editing some code, when I pull your changes in, it'll merge in your changes to merge with my changes. Operational transform has a facility to write a function that does that merge. And the way that you write that merge function, you often end up, and this is how Share.js works, it's conflict free. So my individual characters will get merged in with your individual characters. And we just see each other's typing.
Hang on. How does that work? So if you're sharing some JSON and I delete a field and you modify the field, isn't that a conflict?
Well, so you can decide what to do in that case. The way that Share.js handles that is that if you delete the field while I'm editing the field, then the field gets deleted and all my edits get deleted too. So it's not necessarily what you want in all cases. This is something I'm looking at replacing the JSON type, and this is something that we're looking at changing, that particular case. But you have to be very careful with OT, and specifically if you're using the built-in types, it's there's this kind of interesting field of knowing what all the different operations do when they happen collaboratively. Realistically, if you delete a field while I'm editing it, then tough luck for me, right? If you saw my changes before you hit the delete button, you'd probably still hit the delete button. So, my changes get deleted anyway. But it's great for things say if you have a JSON document that has a list in it, you and I can both be inserting into the list at the same time. And our respective inserts into that list are going to be automatically merged correctly so that they all appear in the right places in the list. If someone else deletes something from the start of the list, then when they see my change, they're not going to think that it's in the wrong place. It all just kind of works, which is really amazing.
Just to clarify a little bit, this isn't federated, so it's got to both point to the same server to do at least passing the data around, right?
Right, exactly. Yeah. So it's designed for basically Node.js web apps. And there's one server, and then your browser then connects to that server these days via WebSockets. And then the server manages all of that. Share.js now supports multiple servers, so you can have multiple front-end servers, but ultimately there's still a set of servers that all of the clients are connecting to. That said, though, basically every time I talk about this, someone asks me that question, and it's a question the question of could we do this in a federated way? Could we make it so that we have multiple servers and we have these documents that are long-lived that people can communicate in and between their different servers? And this is something that I really care a lot about. And actually, to the point that, and this is really exciting news that I haven't told anyone, I've recently accepted a job offer in a company in London called Spatch, and we're actually looking at doing this. So I'm moving over there really soon, and our plan is to start. Obviously, this is really early days, but we're talking about building exactly this, a version of Share.js sort of thing that also will be federated and distributed, and hopefully we're considering doing end-to-end encryption on it. So it'll be a fantastic messaging platform that people can use to build applications. One of the things.
So Joseph, I'm not totally sure I understand what federation means in the context of a operational transform or a shared document. I understand what it means to have a couple of people editing the same document and having their edits appear in real time for them, but what do you mean with federation?
Well, take email, right? Email is quite different from Facebook because at Facebook, all of the messages go through Facebook. And with email, if I am at a.com and you're at b.com and I email you, then the email goes from me to my server, to your server, to you. There's no, centralized authority that, gets to control the entire platform. Federation in an OT platform is kind of similar. The first thing that we need to do is move Share.js from something that works kind of like Subversion to something that works more like Git, where anyone who's on a document can push and pull their changes to everybody else who's also looking at the same thing. So obviously the first thing that would allow is, if you wanted, you could build an OT-based, source control system if you wanted that. But then beyond that, it means that if people want to build a product, products that are more say something like email, except email with collaborative editing. So it's a weird hybrid merge of email and Google Docs. Then there's no one true site that you have to go to be able to access this product. You can host it yourself. And I can host my own version of it, and I can open a Spatch Wave email collaborative editable thing with you, and we can both be like talking about, where we're going to go on holidays, with a blurb at the top of the whole thing describing as we're conversing, we just go back and edit the master plan. So that's the dream, that we have this kind of, system that will let us just be able to arbitrarily edit documents. And this is, sorry, I'm just getting into my regular rant. You guys should absolutely be interrupting me a lot more. One of the things I've been seeing with JS.
Jameson's just too nice.
Right. Yeah. One of the things we've been seeing with JS, and this is something that I did a lot of work on at Lever. So it turns out that if you've got obviously most web apps, right? Like you've got some JSON documents and you've got some JSON stuff, which is your model, and then you want to render that. So you have something like React, and then you render your JSON objects into HTML in the browser. And then as the user interacts or as the data gets modified, then in the browser you'd say, hey React, my data was changed in this way, please re-render the DOM. With Share.js, and this is really cool, with Share.js you kind of get all of the data side of that whole picture for free. So a web app can just synchronously make changes to the local data model, and as they make those changes, then everyone else can just see the changes live, and that all just works. And and synchronously in the browser, you don't even have to care that there's anybody else in the world. You're just making changes to this data model and keeping that data model visible in the local client. And then Share.js takes care of keeping that data model in sync with all of the other clients that are also looking at the same data. But, and this is the thing that gets really exciting when we get into the federation context, it means that with both of these kind of powers combined, we might end up with some sort of awesome platform where people can actually build web apps. And I still have no idea how they're going to be hosted or all sorts of different considerations. This is still very abstract, hey, we're building this cool thing, or, what can we make stage. But we can make something where people can build a web app, but the web app isn't the data itself for the web app is hosted by the platform. So you make a web app, and then everybody else who has a Wave server can use your web app with their own data without any of the data going to your servers. All the data gets stored on their servers in their company. If messages don't, if no one else outside the company is on the document, if no one outside the company shares that conversation or that collaboration piece, then the data will never leave your company, just like Git, right? Which is really cool.
So when you talk about these merging algorithms and operational transformation, it reminds me of distributed systems and CRDTs, and how that seems like a concern that people have had a lot on the back end, where you have to manage these concurrent updates and how do you resolve conflicts and things like that. Is there any overlap with distributed systems and this kind of research?
Well, absolutely. I mean, distributed systems is a catch-all term for anything that's distributed. So this is a distributed system because it's distributed across multiple servers, multiple computers. For CRDTs, though, you're absolutely right to bring that up. CRDTs are in many ways seen as a newer version of OT. Really, they're
we should probably define that. Sorry.
Yeah, sorry. CRDTs, oh god, I can never remember what it stands for. I always think of it standing for commutative replicated data types.
That's it. Ding, ding, ding. Winner.
There are people that disagree.
Yeah, I think the C cannot stand for commutative and instead stand for something else like collaborative.
Yeah.
Anyway, whatever. CRDTs, the basic concept of it is say if you take something like Git, if you send me a commit and I want to merge that commit, then I need to know that commit and all of the history, all of the operations, all the other operations that you've done that I don't know about, right? And I look at all the operations that I've done since then, and I do a merge, and I look at all the operations together, and I say, hey, when you did that commit, I did this commit, those commits merged. They conflicted in this way, or they merged in this way. With CRDTs, you take the document, and the document kind of comes along with its entire history. So the document, in a sense, stores every single operation, every single change that's ever happened to it, so that you don't have to worry about keeping all of these operations around. You don't have to say, oh, well, but what if someone comes online and they only got and they've known about the document, they've had operations since 2 years ago. With OT, you have to keep every single operation for the last 2 years. With CRDTs, and you have to keep them in a database somewhere. With CRDTs, all of those operations are baked into the document itself. So you don't have to keep them separately. So there's less bookkeeping, but then your document ends up growing without bounds. So that's the trade-off. CRDTs are getting a lot of popularity lately. I still think there's a lot of benefit in keeping it simple with operational transform, but I mean, it's something that we're looking at and we're wondering if we should be using CRDTs instead. They're basically in many ways the same technology. The implementation's slightly different. Yeah. So if you see CRDTs banded around, you'll often hear OT banded around as well, because they're basically two technologies, two very similar algorithms that do very similar things.
So
Do you think
I've got some questions for you. One
Sure.
is Bitcoin.
Yeah.
Can you, well, maybe Bitcoin is just kind of off in left field and nobody knows what it is, but how does the way that you're doing these shared updates relate to kind of like how Bitcoin does it?
Well, the whole point of the Bitcoin algorithm is that you end up getting, through a distributed system, you host, like, Share.js relies on right now, it relies on a version number that increases by 1 with every single change that happens, right? And it's just really, really simple clock. The way that Share.js's core algorithms work require that single number to be incrementing every time an operation gets applied on the server. Bitcoin, the algorithm of Bitcoin takes a distributed network and through a ridiculous amount of work gives you a shared number that increases by 1 every time a new block is mined. So you could use something like Bitcoin to actually run Share.js in a distributed way, but no one would be able to merge their operations until they waited 10 minutes or until the next block is mined. So that's what Bitcoin does, which is amazing because the whole point of Bitcoin is that we can take algorithms like financial transactions and, which require a shared lock in a sense. And then Bitcoin can provide that shared lock by doing all of this extra work. And then that means that now we can suddenly have a distributed currency system and a distributed everything else. And this is why lots of distributed people get really excited by Bitcoin as a concept, as an algorithm, because it lets us do all of these things. The thing that people don't talk about as much is that it does it really badly. But yeah.
Well, I'd be interested to hear more about that, but I can't remember the name of it. I've just been searching just now, can't find it, but there is a new mail service that's based on GPG encryption, or maybe it's not a service yet, but it's like a project, and it's kind of like Bitcoin in that everybody, like there's a shared blockchain type thing, and everybody sends their encrypted message to it, and then like everybody checks it all the time to see if there are any encrypted messages that they can decrypt, which means that they're for them. So like a network of people can be like the laptop, in essence, could be quote unquote the server. And every time a laptop comes online, it connects to other like friend laptops, and friends store each other's messages and that kind of thing. Like, what do you think about that? Or,
well, I mean, that's really cool. The big downside to it though is that, how many emails are sent every day? Like, it's a lot, right? Like, it's in the terabyte range, like of bytes. I don't have that much bandwidth. Like, that system is really cool, but it scales linearly with the number of messages. And there's probably ways that you can shutter it off and say, no, this is just our little private network for just our college or whatever. But then now you're back to the same problem. Like, one of the nice things about Federation is that we have exactly the opposite thing going on, that actually your server only finds out about messages that are for someone in your company, and you only find out about messages that are for you. So the whole network scales as the internet scales, which is beautiful.
So we've talked a lot about a lot of different things. It seems like there's kind of a broader trend right now of people realizing that client-side applications have more in common with distributed systems than they used to think with real-time stuff, and especially with Share.js where you're collaborating with multiple people at the same time. Is that a broader trend, do you think, where we can't just hide all that complexity on the server, but we have to deal with it in JavaScript on the client?
I sometimes imagine the world, have you seen those little videos of stuff swishing around inside the sun, and then the sun has these little jets of fire that shoot out, right? Because there's some pressure that has to get released and it gets shot out.
Some science juice.
Yeah, some science juice. Yeah, I feel like a lot of the things that go on in the open source world are kind of like that, and there are something like this IO.js and, things like it. There's these little communities of people that just push really hard for a short period of time, and then something kind of shoots out the side. And then sort of perpendicular to that, there's some other people who are working on something else that then shoots out a different way. And sometimes they they hit each other and they swirl together, and then they, end up, interacting with each other positively or negatively, or just making both of their projects different. I feel like there's this push at the moment, the decentralized push, where people are saying, hey, I don't want Facebook to be in the middle of me and the person I'm talking with, because ultimately, there's no way that we can, in the long run, provide security in a situation like that if the government can always just ask Facebook, picking on Facebook, ask Gmail for all of my emails, right? So if all of the communication that I have goes through Google, then the government can always just ask Google to see all my communication. And that's not, I don't want that. I don't want them reading all of my stuff. So there's this push now for like re-decentralizing everything. Hey, we've got the internet. That was cool. Then we made a whole bunch of centralized applications. And that was pretty cool. Like we made a whole bunch of like new ways to communicate, and we had people in charge of those. So they didn't just like languish in the, in like, hey, we want to make this change, but we can't because everyone's got an installed version and that would break backwards compatibility. And now there's a new push for taking all of that stuff and saying, hey, let's actually like take a lot of the things that we've learned and then make a distributed system again. Like let's build something that works like the internet does. And, like let people actually like communicate by sending a message from my computer to my PC. Like it's crazy that when my friend's in the next room and I want to send them a link, I send them a link over GChat, and I'm in Australia right now. So that message goes to the US and then all the way back from the US and gets to their room. That's still faster than like reading out the message or any other way that I can send that message to them, but it's also like dumb. It's super dumb. It doesn't work offline. It's got all these problems. So yeah, like there's this new push for like, to have these new richer client web apps. And there's also a whole bunch of like crypto stuff that's going on in the JavaScript world. And a lot of it is this sort of idea like, oh, people actually have like rich applications. Actually, I was chatting to my uncle who's been in the computing world for like, since before I was born. I'm not that young. He's just, I don't know, he seems old to me. He got an electrical engineering degree and he worked at Tandem and who bought his old company Burroughs, I think it was. And he was telling me about these, like, the first hard disk that was in Australia that they got. And it was this, like, giant metal drum that took about a minute to spin up to speed. And like this giant disk of copper that they had to install. Anyway, it cost them like over $1 million for a 10 megabyte hard drive, which was huge. But he was saying, like, there's obviously, like, the whole computing history has been a history of people moving to thin clients and do all the work on the server, and then rich clients that do all the work on the client, and then with dumb servers, and then back and forth and back and forth. And, like, in many ways, like, as much as it's glib to say so, the new push for, like, rich client applications is the same thing all over again, right? We had the web, now it's dumb clients again. Okay, and now we've got JavaScript in the web, and JavaScript can do all these amazing things. We have WebSockets. We have ways for using WebSockets for your client to connect to multiple servers, which now lets us do a bunch of distributed stuff. We've got WebRTC in the works. Okay, great. Now we can go back to having rich clients again, which is going to let us kind of build these networks and systems.
So another question with the federated idea, right? So, yeah. I mean, we pick on Facebook, we pick on Google, but really, if the NSA, like, email is really federated, right? Like, right. I mean, it is stored on web servers, but the idea is that it's a federated protocol that I can send from one provider to another provider, right? And it gets to me. But still, there's only, in any realm of competition, there's only like 3 main companies that generally rise to the top. There's Microsoft, Apple, Google. There's Gmail, Yahoo, Hotmail. There's Blendtec, Vitamix, and Ninja, right?
Right.
Like, and so, like, let's say we have this awesome federated capability. Like, how would we get that service out in a way that it's not just federated between 3 or 4 companies, but like it would be truly federated in this more private sense?
Right. So, I mean, I guess I still use Gmail. For all that I complain about centralized services, I love Gmail. I think it's a great product. I think the people who make Gmail do a great job. I really like email being federated, because it means that if Facebook goes evil and decides to sell all my data to companies, then there's nothing I can do. But if Google goes evil, I can move all my data away. Like, I mean, I'm sure there's lots of people who really wish that everyone did actually run their own servers, but I'm actually not all that worried about it. Like, I think that if we have a federated system, a system that can federate, and then all of a sudden, like, and there's only a few monopolistic providers, or a few providers that actually, like, like Spatch, that will end up running our own servers that then people can use, and we will provide the system for lots and lots of users. That's our hope. But we also base this on an algorithm and a system where you can actually host it all yourself if you want to. I think that you end up with something where people can then feel free to, like choose your own adventure server style, where, I use GitHub, but then if GitHub turn into massive jerks, then we can just, like, have our own Git server. And that's, it's going to take some work to set up, but we can set that up ourselves. I personally really like that. I like giving people that sort of freedom, even if they don't actually exercise that freedom and just end up using whichever the big providers are. Like, what do you guys think? Do you think that it's important that we actually do move away from things like Google and Facebook for email?
Man. I feel like it's important, but I don't know if I have ever put my money where my mouth is and actually done anything about it. It feels nice to say I think it's important, though. That feels good.
Well, I get more and more annoyed by them, but like with Google, you can reasonably replace some of their products with competing products or make something, if you wanted to build it yourself. But with Facebook, that's where, I mean, it's completely not federated. There's no way you could build a competing Facebook because you wouldn't be able to message anyone on Facebook.
Right.
So I think Facebook is worse than Gmail is, because if Gmail really gets sucky, well, I use Mailgun and I do some stuff there and I forward a few things back and forth.
You know, I went to a conference up in, it was Open Source Bridge in Portland, and they had kind of a keynote about getting out there, building distributed systems like you're talking about, so that we could take back the power that we were losing with, you know, the NSA and this lack of federation. And it was all well and good, but when it comes right down to it, very few people are building products anybody wants to use that's like that, you know? And there's just so much to be gained from having a company like Google behind who's building your product. I mean, nobody would have built Wave, even though Wave was a big failure. It was still a cool product. Nobody would have got together. 6 people wouldn't have got together and built Wave. It was too much work. And I don't see maybe somebody will replace Gmail.